Hello everybody, my name is Seth. For my discussion problem, I chose a problem from our our chapter 13 homework number 2, problem number 4. It's determining the tangent plane equation at a given point. The problem goes as follows. Z is equal to a function of x and y, which is equal to the sine of x squared plus y plus 1 at the point 1, negative 1, 1. Doesn't seem like a whole lot of information when you first look at it, but once you know the formula, it's all pretty straightforward. The formula reads as follows. Z minus the function of x and y at the point is equal to the partial derivative with respect to x of the point values multiplied times x minus the x value of that point plus the partial derivative with respect to y of the values of the point multiplied times y minus the y value of the point. Pretty straightforward. So all we really need to find here, this value, this value, this value. And then just kind of clean it up and simplify it all out, and we will have our solution. Okay, let's start with partial of x. Let's go with in terms of x and y, first off. Okay, we're going to have to do a little chain rule here. We're going to end up with the cosine of x squared plus y. And then we're going to have to take the derivative of the inside with respect to only x, multiplied times 2x. Clean this up a little bit. 2x cosine of x squared plus y. Okay, now with respect to y, x and y, going to be the same thing, except just a little simpler since nothing's really attached to the y here. We'll keep the inside multiplying by 1. Final for this one, x squared plus y. Boom. Okay, there we go. Now we just have to go through and enter our values and plug it into the equation. So we'll start with the partial of x. Ooh, I'm sorry. This should read, let's write it in red here. 1, negative 1. My mistake. It's equal to cosine 1 squared, and I'm going to be a minus 1 multiplied, now I kind of moved it around, but 2 times 1. Simplifying all this out, we're going to get 2 cosine of 0, which is going to equal cosine of 0 is 1, so 2. Okay, here's one of our values. Let's try to make this one a little neater. Maybe I'll remember what I'm doing here a little bit more, but we'll try this. Partial with respect to y is equal to the cosine of the x value squared minus the y value. This ends up being pretty simple. Cosine of 0, which ends up being 1. Okay, so now we have our two values for our partials here and here. Now, we technically don't really need to find this value if we're given the z value in the point. It should read the same, reading that our x value, our y value, are going to be equal to z as our z value. So, we don't really need to do that, but we will, just to be safe. Ooh, my camera seems to be falling off the mount. Apologize. It's going to be equal to the sine of 1 squared minus 1 plus 1. Break this all down, we're going to end up with 1 as our final result. Subbing all this back in to our equation, z minus the f function at the point 1, 1, 1, negative 1 is equal to partial, let's write this out, multiplied times x minus 1 plus the partial with respect to y of 1, negative 1 multiplied times y, and it would be a plus 1. Okay, we'll enter our values that we found and did the dirty work to figure out. Equal to 2 x minus 1 plus 1 times y plus 1. Moving the 1 over and distributing out all in one step, 2x minus 2 plus y plus 1 plus 1. These are going to cancel out for us. So we're going to get z is equal to 2x plus y. And that, pretty straightforward. We have found, slide it up a little bit, found our tangent plane equation given just the function and a point. We'll load this up into the app and we'll see what happens.